Hello guys, good morning everyone. Welcome back. So this is our day 5 of bridge course for NEET 2026 and I hope you are enjoying these sessions. Yes. So now till now what we have learned in mechanics track of ours is we have talked about the motion in a straight line and the beautiful use of Galileo's formula in that. Then we have talked about the average and instantaneous values on day 2, in which we have understood the fundamentals of finding the average and instantaneous values of physical quantities, and that is not only restricted to kinematics, but those things will also always keep coming in different topics and chapters. Then we have talked about our horizontal projectile motion yesterday itself, and today our topic of discussion is going to be oblique projectile motion, or you can say angular projectile motion. All right. Today we are not only going to discuss the NCERT formula, but we are also going to discuss a lot of modifications, the basic of which I already repeated. I already gave the briefing about in our last session, but today again from the basics, from the fundamental, from the basic to the best, we are going to cover each and every NCERT formula, their modifications and the other type of problems that may be asked to you from projectile motion topic in the upcoming target of NEET 2026. I hope you guys are ready. Good morning here. Good morning Gayatri, Lakshmi, Chandana, Lakshita, Udaya, Shakeen, good morning. Yeah. So are you ready now? Y is equal to ax minus bx square. Yeah, that can represent kind of equation of trajectory. So very soon we will talk about that also, right? Let's start our discussion then. So today our topic of discussion is oblique projectile motion. All right. In this topic of oblique projectile motion, what is the meaning of the term oblique? Here oblique, we are referring by the term oblique that the projectile, that the object has been thrown making some angle with the horizontal. So yesterday also I told you this, that if you have a ball in your hand and you throw it vertically up, so it is vertical projectile. The thrown object is called projectile. The action of throwing is called projecting an object. Okay. And motion under gravity thereafter will be commonly called as a projectile motion. Later, in our later discussions, we will also see that whenever an object is thrown or introduced with a certain velocity in electric field or magnetic field, then also we will consider the projectile motion there. But here, our discussion is restricted to the motion in the influence of gravity. Very soon, we will also introduce the air friction, and then we will compare the ascent and descent part of our journey. I hope you are understanding it, what I am saying. I am saying that projectile is an object which has been thrown. It is not released, it is not dropped, it is thrown with a certain velocity. Oblique projectile is referring to that the object has been thrown making some angle with the horizontal. All right. And its motion we are going to study today. Right? Chalo. So first of all, the concept of oblique projectile motion. So let me draw the two axes. Our basic logic of discussion of any of the motion in a plane is that we don't want to discuss the motion keeping the plane itself in our mind. Rather, we want to break this motion along two perpendicular axes, x-axis and y-axis. The beauty of analyzing motion in a plane by breaking it along two perpendicular axes is that these two perpendicular axes are going to be independent to each other. That means while having a discussion of motion along the x-axis, we must ignore what is happening in the y-axis. While considering the motion in y-axis, while considering the vector physical quantities in the y-axis, we can simply ignore the quantities available in the x-axis. Okay, so that's whatever we have done yesterday, that's what I'm going to do today also. So let me show you diagrammatically what is happening here. So basically, let us consider this as our x-axis, and then we have here y-axis. Okay, and This is my x-axis, this is my y-axis, this is my origin. Origin, I can take it as a point of projection. There is an m mass object thrown with a certain velocity u, making a certain angle theta. Okay, m mass object, u is called the velocity of projection, the velocity with which you have thrown, you have projected the particle. And theta is called angle of projection. Theta is the angle of projection generally made with horizontal. It's not necessary that every time it will be made with horizontal. Generally it is made with horizontal, but not necessarily. Okay, angle of projection, angle of projection, generally but not necessarily made with horizontal. Sir, what if in the question examiner is telling that the angle is made with vertical? What if in the question in the exam, examiner is mentioning that the angle is made with vertical? Then no worries, whatever formula we are going to learn today, if theta, instead of making theta with horizontal, if you want to make the theta with vertical, then whichever formula we are going to learn today, you are supposed to replace sine theta by cos theta and cos theta by sine theta. Okay, we are supposed to replace sine theta by cos theta, and we will replace cos theta values by sine theta. Understood? If instead of horizontal we make the angle with vertical. Okay, we'll come across that. Now what is happening here? I would say that suppose at t equals to 0, suppose at t equals to 0 you have thrown this particle, then covering its journey like this and assuming, say, no air drag, say assuming no air drag, assuming no air drag or air friction, there is no resistance offered by the air, which means once thrown from your hand, now onwards, once thrown, you have projected it with a certain velocity. Once you have thrown the object, after that its motion is only going to be governed by gravity. Okay, the projectile is only moving under the influence of gravity. So if this is t equals to 0, then it will land back on the ground itself at t equals to capital T. Under the influence of gravity, it will land on the ground. It will come on the same horizontal level. So if it comes back on the same horizontal level at t equals to t, this capital T here for our discussion, that is going to be time of flight. Time of flight, the time for which the body is flying in the air. The time for which the body is flying in the air under the influence of gravity here. Okay. Throughout its flight, throughout its journey, throughout its flight, whatever distance it covers in the horizontal direction, that is called horizontal range. I repeat, throughout its flight, throughout its journey, whatever is the horizontal distance covered, that is, or displacement covered in horizontal direction, that is defined as horizontal range. Horizontal range. All right. Similarly, throughout its journey, you can see for a while it was going up as well as forward, and for the later half it is going down as well as forward. So for the first half it is going forward and upward, and then it is going forward and downward. So throughout its journey, whatever maximum height it traveled or whatever displacement maximum is covered in y-axis. See, eventually it is coming back on the x-axis. So in the overall projectile motion which I have shown on the board, there is an effective displacement only in x-axis, but in y-axis it is coming back on the ground. So in y-axis there is no effective displacement. Understood? So what we can see here is that maximum displacement whichever is covered in the y-axis, maximum displacement, that can be called as maximum height. So I will say here, the third thing is we need to understand is maximum height. Maximum height. All right. H max. Maximum height H max. And the fourth thing is, sir, what is the nature of this path? Is it a random curve? Yesterday also I was emphasizing on that you are drawing this curve It can be a random curve, it can be a part of a circle, ellipse, parabola or hyperbola. Your feeling will not give you the answer, what exact curve it is. The equation of trajectory or the equation of curve will sure tell you that exactly what portion it is, what shape it is. Okay, so it is going to come as a parabolic shape. It is a downward parabola, parabolic path. But how you are commenting that it is going to be a parabolic path? You are going to comment that it is parabolic on the basis of equation of trajectory. So before talking about any of these things which I have mentioned on the board, I would again like to emphasize on what do we know in x-axis and what do we know in y-axis here. So I will say in x-axis and in y-axis. In x-axis and in y-axis. In x-axis, the convention will be forward positive, backward negative. In y-axis, this will be the convention that forward it is positive, backward it is negative. Okay. And in the y-axis, the convention would be upward is positive and downward is negative. All right. In the x-axis, convention is for vector convention. While writing the vectors, instead of writing instead of only considering the magnitude, since all the motion equations are vector equations, we have been talking about it from day one, right? All the equations of kinematics, motion equations are vector equations here. So we must be considering the sign convention. So along the x-axis, forward vectors positive, backward vectors negative. In the y-axis, upward vector positive and downward vectors negative. So what we will get here, we will say initial velocity in x-axis, that will be positive of u cos theta. Acceleration in x-axis, that is 0, because there is no air friction and gravity is the only force, or gravity is the only reason available there to change the velocity. And what is the direction of acceleration due to gravity or gravitational force? The weight, that is vertically downwards, which means it is not along the x-axis, it is along the y-axis. So if I comment about, see how we are getting this velocity, let's have a close look here. This is u making an angle theta. So can I break it into, here you will get u cos theta and here you will be getting u sin theta. So along the x-axis, you have an initial velocity of u cos theta. Since it is forward, I am writing it as positive. Similarly, along the y-axis, you will say uy will be equal to, since it is upward, I can write it as positive of u sin theta. And here ay will be equal to minus g, which is constant. So by nature, if I comment that what is the nature, same as the horizontal projectile motion, here in oblique projectile motion also, the nature of motion along the x-axis and y-axis, separately we will comment. Why separately we will comment? Because these are going to be independent axis. All right. So I'll simply say that along the x-axis, when you are considering anything, you can ignore what is happening in y-axis. And when you are considering the motion along the y-axis, you can ignore what is happening in the x-axis. That is the key rule for projectile motion. So the nature here, nature of motion in the x-axis is uniform motion. The nature of motion in x-axis is uniform motion. Why, sir? Because there is no acceleration available here. And the nature of motion in the y-axis, because there is a constant acceleration available there. Constant acceleration. So you will say this is uniformly accelerated. Uniformly accelerated motion. I hope everything, whatever I have mentioned in terms of details, everything is clear to you. Just have a close look. And any doubts you have, you can post that on the live chat and the comment section. Live chat, in fact. I can see that. I would answer all of your doubts. Okay, related to the topic, dear, whatever other doubts you are asking, we will be interacting separately for that. Okay, so what we have understood in today's discussion, the meaning of oblique projectile motion, angular projectile motion. If we talk about angular projectile motion, then definitely the meaning is projectile. We are projecting an object. Okay, projectile is the thrown object. We are throwing an object in the air, and for simplicity, first of all, we are assuming that there is no air friction. So when you are throwing an object in the air and there is no air drag, there is no buoyancy, nothing. So the motion of the thrown object will be influenced only because of gravity. Okay, and near the Earth's surface, we are again assuming for our range of motion, there is no variation in acceleration due to gravity. Although you know that if you go up to great heights, or you go inside the depth, or you go at different places, even on the surface of the Earth, acceleration due to gravity value varies. I hope everyone knows that. And the moment acceleration due to gravity value will vary, say here as per the height, then definitely you can't call it uniformly accelerated. You can't call it uniformly accelerated. You are permitted to call it uniformly accelerated only if you are assuming that your range of motion, your height is so small that there is no variation in the value of acceleration due to gravity. So if there is no variation in acceleration due to gravity, y-axis motion will be uniformly accelerated, and in x-axis there is no force, and hence x-axis motion will be uniform motion. Okay, with constant velocity in x-axis. This u cos theta will not vary with time because there is no one to vary that. Which physical quantity is responsible to vary the velocity? You will say acceleration, sir. Force, sir. There is no acceleration available here. So the velocity component along the x-axis doesn't change throughout. I repeat, the velocity component along the x-axis doesn't change throughout. The velocity component along the y-axis will keep on changing under the influence of gravity. Very soon we will see how the x-axis and y-axis displacements, acceleration, velocities, how these things will vary with time. Like last time we did in horizontal projectile, acceleration as a function of time, position vector as a function of time, velocity vector as a function of time. Today also we will see that, but in a while. First of all, related to this motion, there are 4 different things, NCERT topics, 4 different things important for NEET written in front of you. Okay. Any doubt in the diagram? Or is it clear? If it is clear, then one by one I will explain and I will tell you how do we get these different 4 results. Any doubt anywhere? No doubts? Okay, keep posting if you have any doubt in the live chat. I'll be answering it very soon. Let me take you towards the first topic, that is time of flight. So dear, time of flight means time of flying, the time for which the body is in the air. Time for which the body is in the air. Technically speaking, time after which the body lands back on the ground. If the body lands back on the ground, means if it lands back on the x-axis, its y coordinate is going to be 0. But since your childhood, you have been talking about this, that on any point on the x-axis, y coordinate must be 0. Similarly, on any point on the y-axis, x coordinate must be 0. So here, what we can write as, since we want to find out the time for which the body is in the air, we indirectly want to find the time after which the body will come back on the x-axis. And where on the x-axis? R distance, that we don't know. We are yet to find that. Okay, where on x-axis? R distance, but we don't know that. What will be the y coordinate? 0. We know that. So whose information we already have? Y coordinate. So for calculating the time of flight, I'll be emphasizing on the y-axis. That means if I say s equal to ut plus half a t square, I'll write it as sy will be equal to uy into t plus half ay into t square. What I am doing, I am indirectly restricting my analysis only in the y-axis. So when you come back on the ground, your y coordinate will be 0, and that will be equal to positive of u sin theta into capital T plus half into minus g into capital T square. So it's a quadratic equation in T. Once you are solving this quadratic equation, you are getting T equal to 0 or 2u sin theta by g, or T equals to 2u t equals to 2u sine theta by g. Okay, so what I'm saying is this t equals to 0 represents initial situation. It represents initial situation here. Initial situation means what, sir? We have mathematically applied the condition that when will be y coordinate 0. So boss, y coordinate is 0 at two different times, initially and finally. So initial is this initial moment, and or you can say initial point, and this t is equal to 2u sine theta by g. T is equal to 2u sine theta by g is basically representing the time of flight. That is basically representing the time of flight. So first formula I want you to remember is t is equal to 2u sine theta by g. Remember dear that this time theta is made with horizontal, or theta is made with x-axis. What if the angle of projection is made with y-axis, sir? Then as I said, that sine theta will change into cos theta and cos theta will change into sine theta. So here let me add it on. If angle is made with y-axis, if angle is made with y-axis, then you will say, sir, sine theta will change into cos theta and cos theta will change into sine theta. Sine will change into cos and cos will change into sine. A very small, a very nice tip to avoid any kind of errors, which means whenever you are trying to solve any numerical problem based on projectile motion, one thing you always have to emphasize that angle of projection, if they say angle of projection, then it is by default made with horizontal. All right. But if they say the ball is thrown making an angle 30 degree with the vertical, then what will happen? Then you want to use 30 degrees as theta. Then all the formula which we are going to talk about here on board, remember that sine must be changed into cos, then put the value of theta, or cos will be changed into sine, then put the value of theta. Okay. I hope that's clear. All right. Okay. Once again, I am explaining it that time of flight is that time after which the ball comes back on the ground, comes back on the x-axis, so that its y coordinate will be 0. Okay. Suppose we talk about horizontal range. So horizontal range is defined in horizontal, obviously, that throughout its journey, throughout the time of flight, what is the horizontal displacement covered? Throughout its journey or throughout the time of flight, what is the horizontal displacement covered? That is defined as horizontal range. So in which axis we are interested this time? We are interested in x-axis. So Sx will be equal to ux into t plus half ax into t square. So see, Sx will be plus r. Why, sir? Because according to this diagram, range is covered in the forward direction, and our convention in the classroom is along the x-axis, forward positive, backward negative. And in the y-axis, upward positive and downward negative. So that will be equal to ux. Ux is plus u cos theta. See, in the table, I have already written it for you. It is plus u cos theta into capital T. And this ax here is 0. Ax here is 0. Now, the moment you will substitute the value of capital T over here, you will be getting the value of range as u square sine 2 theta by g. U square sine 2 theta by g. Okay, that's the formula, u square sine 2 theta by g. I hope everyone knows here sine 2 theta is always written as 2 sine theta cos theta. Sine 2 theta is always written as 2 sine theta cos theta. That's clear? All right. Maximum height. What you can see and how do you define the maximum height? Technically, we say throughout its journey for first few moments, projectile or particle is moving forward also, upward also. And after some time, it will be going forward also, downward also. So for first, upward, forward, then downward, forward, upward, forward, downward, forward. Throughout its journey, whatever maximum displacement it covered in y-axis, that is defined as maximum height. Again, this time, so during the time of flight discussion, we talked about y-axis. During the horizontal range discussion, we talked about x-axis. During the maximum height discussion, again, we have to talk about y-axis. So, what I'll write here is Sy will be, okay. Now, the condition at Hmax is, so for the before Hmax, the y component of velocity was positive. After Hmax, the y component of velocity is negative. Before Hmax, the y component of velocity is positive. After Hmax, the y component of y component of velocity is negative. But at Hmax, the Vy value will be equal to 0. The Vy value will be equal to 0. At Hmax, Vy is 0. So I'll apply third equation of motion. Instead of second equation of motion, I'll apply third. Vy square is equal to uy square plus 2 ay sy. Then you will say final value is 0. Initial value was plus u sine theta, its whole square, plus 2. Ay is minus g, and here we have Hmax. So from here, Hmax value is coming as u square sine square theta by 2g. U square sine square theta by 2g. Alright, is that understood? है ना? अच्छा, equation of trajectory. Equation of trajectory. Why this equation of trajectory is important, sir? Last part for this slide, है ना? There is not much space available also. But yeah, there are a lot of things to be discussed. First of all, I prioritized to tell you, to teach you the concept of projectile motion and all the NCERT related things, directly related to NCERT or directly picked from NCERT. The modified cases we will keep on talking. Meanwhile, we'll also see some NEET PYQ, some special type of problems and special way of doing the problems also. Alright. So equation of trajectory. Yesterday also, or every time I say in all the topics that equation of trajectory or equation of path, or in common terms equation of design, is obtained after relating the x-axis variable with y-axis variable, or you can say x variable and y variable. If you want to know what exactly the design is, which exact shape it is, then you must be establishing a relation between x and y. The relation between x and y will tell you that what shape exactly it is. For example, a linear equation in two variables in x and y always represent a straight line. If one is linear, one is quadratic, generally it represents a parabola. If both are quadratic, equal coefficients, plus sign in between, it is going to represent a circle. Both are quadratic, unequal coefficients, plus sign in between, ellipse. So there are different cases. At right time, one day, I told you in graph section also in this bridge course that phase 1 of understanding the graph is use of calculus, which we have completed. But phase 2 is all about the equations and shapes. So whenever we will take care of that, you will understand that I am emphasizing on this, that you don't name it. You don't name a design by looking on its shape. In fact, the name of the exact design will be known to us only if we are able to find the equation, only if we are able to find the relation between x and y. So dear, conclusion is, whenever you have to talk about equation of trajectory, you always have to establish a relation between x and y here, in this case in 2D. Okay, so what I can write is in x-axis separately and in y-axis separately, just like I did in the horizontal projectile last session. Sx is equal to ux into t plus half ax into t square. The moment I write it, ax is 0. As you can see from there, there is no acceleration in horizontal direction. Let us say that any random displacement covered in x-axis, since you have started from origin, right? Whatever displacement you cover in x-axis, that will be your x coordinate, x. And that will be u cos theta into t. U cos theta into t. This implies t will be equal to x by u cos theta. T will be equal to x by u cos theta. Alright. Now you write the same in y-axis. Sy will be equal to uy into t plus half ay into t square. Ay into t square. The moment you will substitute it y, uy is u sine theta, t value is x by u cos theta from here, plus half acceleration in y-axis is minus g. It is again x by u cos theta and its square. And its square here. Okay. So the final equation of trajectory is y is equal to x tan theta. See, u and u got cancelled. Minus gx square over 2u square cos square theta. So what I'm trying to say is, this is the equation of trajectory as per the NCERT. The interesting part in this equation of trajectory is, one is quadratic and one is linear. See, y is quadratic and y is linear and x is quadratic. And on one fine day, I will definitely get into the details of this. But for today, you just casually remember it, that linear equation in two variable always represent a straight line. If one is linear, one is quadratic, parabola. Both are quadratic, it can be ellipse, circle, hyperbolic. On one fine day very soon, we will talk about too many details regarding this. Then you will have a clear-cut idea. As of now, for today, it is the equation of trajectory as per the NCERT, and since this equation of trajectory is an equation of parabola, that's why you say that it is a downward parabolic path. You just don't say downward parabola because it looks like a parabola. No. Look will design by your interpretation. Interpreting the design will not be a correct way of naming it. The equation will tell you what exactly it is. Otherwise, it could have been a part of the circle also here. Okay, semicircle also, like that. There could be many possibility, but equation will tell you what exactly it is. I hope we have discussed a lot of things on this slide. Maybe you can find also font size a little bit small. Prefer to review this lecture once again in your laptop screens or tab screens instead of mobile phone. Later, it would be better. I hope everything is clear to you. I have repeated everything several times so that that can go and get stored in your head. Yes, there are many details, but the good part and interesting part is all the things which are mentioned in NCERT. First of all, we are happily able to emphasize on that and put some sort of closure to that. Now we will elevate our level. We'll understand these things in details and some screen also. Hey guys, so there was a technical glitch in between. Let me know in the comment section. Am I clearly audible and visible to you? Yeah. All right. I think yeah, I can see that. Now, so these are the 4 things where which we have discussed from the NCERT part, and let me take you a bit ahead, and then very soon we'll start with the problems also. So again, we are talking about this oblique projectile motion. A quick recap for all the new learners, and we'll sum up in a much better way. So this time, this is x-axis, this is y-axis, this is origin. What do we have? We have a projectile of mass m. Mass m may come into the picture when we consider the air drag, air friction. But here, there is no air drag, no air resistance. So initial velocity or velocity of projection is u, angle theta. So you will say that, this is u cos theta, this is u sin theta. And under the influence of gravity, definitely it is going to cover a parabolic path, downward parabola. These things we have considered till now. So first thing, I'll rewrite it again for you. We talked about time of flight. Time of flight is basically time of ascent and time of descent. Sum of time of ascent. Time of ascent is the time for which the body is moving up plus time of descent. And here, because there is no air drag into the picture, I will write that time of ascent must be equal to time of descent. Both are equal and both are half of time of flight. So instead of 2u sin theta by g, you will get it as u sin theta by g, And there is another modification glitch which I have emphasized on, that instead of taking the angle with the x-axis, if you make the angle with the y-axis, then definitely sign will change into cos. So better to remember it as uy by ay. That's the thing. Or in a better way, much better way, you can write it as u vertical by acceleration magnitude in vertical direction. Well, initial velocity in the vertical direction by acceleration magnitude in the vertical direction. That's g here, gravity only. And the total sum of ascent and descent, which is nothing but time of flight, that was 2u sin theta by g. This is valid. This thing is valid if air resistance is ignored. Okay. That is the situation. I hope that's clear to you. Now, suppose we talk about the horizontal range. The other thing which we have taken into account, horizontal range. On the previous slide, that horizontal range is given by this horizontal range R, that is given by, formula is u square sin 2 theta by g. But how do we get that? We multiply the ux with t, time of flight, which can be written as ux, and the time of flight we have seen that is 2uy by g. So here you can write it as or twice of uy by g, or you can write it as twice of u vertical by a vertical. Why we are writing vertical and horizontal, sir? Why? Like x-axis and y-axis was fine? No. Then where there is a need of talking in about x-axis and y-axis there? So basically, if they mention the vectors instead of 2D, if they mention the vector in 3D, then the situation will be entirely different. I'll show you that. Y-axis. I'll take one case of 3D. Before that, let me write every formula in terms of horizontal and vertical. So that is twice of u horizontal into u vertical by a vertical. Twice of u horizontal, u vertical by a vertical. Similarly, if we talk about the maximum height, h max, then this h max value will be equal to u square sine square theta by 2g. So basically that is this formula which you have deduced, the NCERT formula which you have written over here is u square sine 2 theta by g. But the actual meaning and the hidden parameters in this formula are in front of you. So I want you to remember this also, how this formula is coming. Similarly, h max is what you have seen and what NCERT is giving is u square sine square theta by 2g. And examiner knows that, you know, a lot of students, a lot of aspirants, they just follow mugging up the formula, memorizing the formula, putting the values and writing the answer. That's not good. That's not good. I always say that maths story, mathematics story ends after, you know, getting a result. Physics story starts from that. You have to get the result, you have to interpret the result, you have to understand the meaning of each and every symbols, you have to see how the situations will be modified, like that. So here we are talking about the modifications also. So u square sine square theta by 2g, which can be written as uy square by 2g, or you can write it as u vertical square by twice of a in the vertical direction. U vertical square by twice of a into a in the vertical direction. Okay, u square by 2g, uy square by 2g. These are the formula. I am not emphasizing much on equation of trajectory. Okay, let me write that also for you. So equation of trajectory, what you have seen is y is equal to x tan theta minus gx square over 2u square cos square theta. I am not a person who you know, prefers to memorize each and every formula. I am less formula biased person. I am more into the logic. But since it is an NCERT formula, you and I must be having all the NCERT formula at least on our tips. Okay. So y is equal to x tan theta minus gx square over 2u square cos square theta. In a better way, that can be written as x tan theta 1 minus x by r. X tan theta 1 minus x by r. Okay. I'll give you one example. So I think the situation is clear to you. Let me give you one example based on 3D. Okay, like why or where these formula will be helpful for you. So the example is, suppose the examiner is saying that this is your x-axis, this is your x-axis, this is your y-axis, and this is your z-axis. Z-axis is basically vertical, xy axis is ground. XY axis is ground and the Z axis is vertical, and this is the origin. From the origin, you have thrown a particle. From the origin, you have thrown a particle of mass m with a velocity vector u vector. Okay. Here u vector, if u vector is given by 3i cap plus 4j cap plus 5k cap, then you have to determine time of flight also, range also, and maximum height also. Once again, I am telling you that xy, this time it's a motion which has been given to you in 3D. In fact, in 3D, x-axis, y-axis, z-axis, xy is a ground, xy plane is basically treated as a ground, z is treated as a vertical. Z is treated as a vertical, and examiner is asking you that if u vector, sir, why they are not giving theta? Why do they give theta? They give theta to tell you the direction. If they are already giving you the vector in terms of I cap, j cap, and k cap, which means they are giving you magnitude as well as direction, complete vector they are giving. So there is no need of any kind of theta. You can't apply directly any NCERT formula. You can't apply directly any NCERT formula here because those things are not known. But if you understand what I have told you here in terms of horizontal and vertical, then within a minute, you can find out time of flight, ascent, descent, range, height, everything for this situation also. Do you want to try? You want to try that? So, how do we do that? If I try to understand this situation, I will say that here, this x-axis and y-axis, in fact, the entire xy plane is treated as a ground or horizontal. So the resultant of I cap and j cap component will give you u horizontal. And this u horizontal will be equal to under root of 3 square plus 4 square, and that is equal to 5. I hope you understand the Pythagorean triplet. And here this 5k cap is also going to represent your uy. So u vertical. So my u vertical, because vertical is z axis. So my u vertical is basically along the z axis, but u horizontal is the resultant of all the horizontal axis vector component. So here x axis is also horizontal and y axis is also horizontal. Okay. In fact, the entire xy plane is a horizontal plane, this plane, and z axis is perpendicular, this one. Okay. I hope that is understood. So here, number one, if they are asking you the time of flight, so that is twice of u vertical by a vertical. So twice of, and you can take here, say the g value, like the g value is written as 10 meter per second square. The gravity is obviously vertically downwards. So t is 2 uy by g, u vertical by a vertical. So you can simply write it as twice of, that is 5 u vertical is 5 by this is 10, and hence it is 10 by 10. The time of flight is 1 second. Time of flight is 1 second. Since there is no air friction here, no air drag, so I will say time of ascent is equal to 0.5 seconds, half of it, and time of descent is also half of it. By symmetry, time of ascent, time of descent. By symmetry, time of ascent, time of descent, both will be half of it and half of it. Okay, there is no air friction. If there will be air friction, then ascent and descent will be different. That we will talk later on. And moreover, this direct formula of time of flight will also not be applicable. Okay. Number two, if they are asking range, then whatever the time of flight is, you can simply multiply it with u horizontal, ux, that is u horizontal into the time of flight. Or you can again start the process by writing it as twice of u horizontal, u vertical by a vertical. But that we already know, time. So just multiply the time of flight with horizontal component, you will be getting the range. So horizontal component, you got it as 5, the time you got it as 1, and hence it is 5 meters. Similarly, if someone is asking the h max, that is u vertical ka square by twice of a vertical. Alright, u vertical square by twice of a vertical, just like stopping distance or normal maximum height formula in 1D, you write it as v square by 2g. Same, this formula is there, but remember we have to consider the vertical one. So vertical is 5, here it's 5 square by twice of 10, so that is 25 by 20. 25 by 20. 25 by 2 is 12.5, another 10, so you can write it as 1.25 meters. I hope the entire logic is clear to you. Alright, so if you just memorize the NCERT formula, you will never be able to deal with such type of situation. If you memorize plus interpret plus implement, understand the modification, then definitely you will be able to handle all the situations, 1D, 2D, in fact 3D, everything here. You can take the screenshot. In fact, let me show you here for a quick revision in between the breaks. You can take the screenshot, although the notes will also be attached in the description of the video by the end of the day. Quickly take this. So this is where we have started our today's discussion. Then you can take the screenshot of this one also. It is emphasizing on the fact that you will get to know that how to study physics. Learning to learn is also very much important here. Take the screenshot here. And you can keep sharing this video, these sessions to your rest of the friends. With friends, the competition is always a healthy competition. Let them learn, you also learn together, and then at right time there will be a healthy competition platform, and we will keep taking a lot of sessions, tests. Once you will be here, we'll have a very grilling session this year looking into the pattern of NEET 2025. Definitely we will see everything starting from the basic up to the best with no pressure. No, I assure you that your entire preparation, and I suggest you in fact that whether some units, some topics may get tough, some topics are easy, but one thing you should try to make it consistent throughout your preparation is this big smile on your face. So keep smiling, stay healthy, that's more important, and maintaining your physical and mental health, then we should keep going along with your preparation. Anyways, life may something big we all have to do, right? So in that case, the only thing is required, that is required is consistency of the efforts. Few days will be, your efficiency will be much higher. On other few days, your efficiency might be lower. But if you keep on, putting your efforts on everyday basis, there is no one and nothing who can stop you from growing. Okay. So just make one thing sure in a very disciplined way, that you keep putting some more efforts towards your goal on everyday basis, right? So here, this is done. Now we will see few more things related to the projectile motion, and then we will start with the problems also. So I have brought few NEET PYQs. So let me take that once again. So another thing is, so till first 4 things we have discussed here, all these 4 things, time of flight, horizontal range, maximum height and equation of trajectory, these are the NCERT things. Now I am talking about condition for maximum range. Condition for maximum range. Now, what is this condition? So now again from the NCERT formula, R is equal to U square sine 2 theta by G. That's the formula. Okay, R is equal to U square sine 2 theta by G. For range to be maximum, you want to throw a ball up to the maximum horizontal distance. So obviously you will be throwing with your maximum capacity. So U is not variable, U is fixed, your maximum capacity. G is also fixed near the Earth's surface. Okay. So R is maximum. For R to be maximum, what you can adjust while throwing is the angle of projection. For R to be maximum, your sine 2 theta must be maximum. Instead of, despite anything, like you put any value of theta, independent of the value of theta, what you are putting here, sine's maximum value is always +1. Okay. That is sine 2 theta. Maximum value can be +1. It can happen only if 2 theta is 90 degrees or theta is equal to 45 degrees. Theta is equal to 45 degrees. This is the condition. What I have written here is condition for maximum range. So this is the condition which you are, looking at. Condition for maximum range. What will be the maximum range, sir? So if you keep this sine 2 theta as +1, the maximum range, what you will get from here is R max, that will be equal to U square by G. And the value of H max at theta equal to 45 degrees. The value of H max at theta equal to 45 degrees, that will be equal to U square sine square 45 degrees by 2G. U square sine square theta by 2G. Sine 45 degrees is 1 by root 2. 1 by root 2 square is 1 by 2. Another 2 is already there in the denominator. So it is U square by 4G. U square by 4G, or you can write it as R max by 4. R max by 4. For example, what I am doing is, suppose I am throwing a ball here. I am throwing a ball here with 10 meter per second at an angle of 45 degrees. Then here R will be equal to, R max will be equal to, R will be, and anyways it is thrown at 45 degrees. So range has to be maximum. That will be equal to 10 square. See, the formula is U square by G. The formula is U square by G, R max formula. So that is 10 square by 10, and hence it is 10 meters. So H max will be equal to R maximum value at theta 45 degrees. It is obviously by 4. So that is equal to 2.5 meters. 2.5 meters. H max dash, language of the problem. Fundamentals are clear, formula are clear, everything is cool and clear, sir. But examiner might ask you a similar but not the same problem. They ask maximum possible. So must be thrown vertically. Means what will be the language of the problem here? If they say that you have a ball in your hand, if they say you have a ball in your hand and you have the maximum capacity of throwing that ball up to 100 meters horizontally, up to 100 meter horizontally. So naturally, when they say that you have a maximum capacity of throwing it horizontally by 100 meter means you are throwing it exactly at 45 degrees. If you're throwing it exactly at 45 degrees, then definitely you can say, if you're throwing it at 45 degrees, definitely you can say H max will be equal to R max by 4. So 100 meters by 4, 25 meter. That will be the height attained during this throw. But if they say in the language, listen to me very, very carefully. If they say in the language that in the horizontal direction your maximum capacity is 100 meter, then what is your maximum capacity to throw the ball in the vertical direction? Then instead of throwing it like this, you will directly throw it like this. If you want to judge your capacity in vertical, why you will be throwing at an angle? You will be naturally throwing it in vertical. So maximum possible when thrown vertically, that will be equal to u square by 2g. U square by 2g, normal motion under gravity. So that will be equal to 10 square by 2 into 10. And hence it is here, how much? It will be 5 meters. All right, 5 meters. So at 45 degrees, when your range is maximum, you are getting 2.5 meter. But if you want to check your maximum capacity in vertical, then definitely you will be throwing the ball in vertical. Judge the language of the problem, English of the problem clearly. Okay, because every time the problem is not of physics or maths. A majority of time these days, the problem also lies in the language of the question. Okay, so I'll keep emphasizing. Don't worry, we will learn everything together. What type of other modifications in languages can be done? Language of the problem. Okay, now let me take another thing, that is Galileo's formula. We all know that Galileo's law of odd number, Galileo gave the contribution, did the contribution in our motion in a straight line also. We have already, we started with lecture 1 by Galileo's formula, but here also this is Galileo's formula and we also call it complementary angle formula. Complementary angle formula. What is this complementary angle formula? Galileo's formula or complementary angle formula says that range, see, range is maximum at 45 degrees. But range R is same at two complementary angles. Two complementary angles, range is same. Obviously, it is not maximum. It is maximum at 45 degrees. So the two complementary angles can be theta and 90 minus theta, or you can say 45 plus alpha and 45 minus alpha. Right? At theta and 90 minus theta, the range will be same, or 45 plus alpha and 45 minus alpha, the range will be same. Let me show you that diagrammatically. So I will say that here at 45 degrees, here at 45 degrees, the range is maximum. This is R max. The range is maximum. Okay. But if you take the angle 45 plus alpha or 45 minus alpha, see what will happen. At 45 plus alpha, this is already 45. If you rotate alpha again here, this total angle is 45 plus alpha. And if it is 45 and you rotate alpha here, this angle will be 45 minus alpha. So at 45 plus alpha, where the particle is landing, at 45 minus alpha also, the particle will land there only. At 45 minus alpha also, the particle will land there only. The range will be same for both. Obviously, the upper curve will have higher value of uy, time of flight, and h max. But the range is going to be same for the upper yellow curve and lower yellow curve. I repeat, for the complementary angles, the range is going to be same. That can be proven easily trigonometrically, but we are not that interested in the proof today. Okay. And if we talk about the uy, t and h max, then that is more for the upper one and less for the lower one. Similarly, I can show you here on this diagram that at an angle theta, and at theta here means this angle as 90 minus theta. If this theta is here, both will land exactly at the same point. both will land exactly at the same point, but not exactly at the same time. The upper curve will have a greater time, so it will be landing later, delay landing. The lower curve is having lesser time, so its landing is sooner landing. All right, they will be landing at the same point, but they will be landing at two different times. Landing at the same point, but two different points. All right. Then we can talk about the relation between range and Hmax. The relation between range and Hmax. All right. So what is this exactly? I will write R. See, range R is equal to u square sine 2 theta by g, or you can say u square sine 2 theta can be broken down as 2 sine theta cos theta by g. And similarly, the Hmax will be equal to u square sine square theta by 2g. U square sine square theta by 2g. Divide. So once you divide, the LHS will have R by Hmax. The LHS left hand side will be having R by Hmax. And the right hand side, you see u square by g will be cancelled. Single sign will be cancelled. You'll get 2 cos theta. And in the denominator you will have sine theta by 2. In the denominator you have sine theta by 2. So that is R by Hmax, and that is equal to 4 cos theta by sine theta. But sine by cos is tan. So let's bring it here. Tan theta will be equal to 4 Hmax by R. Tan theta will be equal to 4 Hmax by R if you see here, if Hmax is equal to R, if your maximum height is equal to range, then theta must be equal to tan inverse 4. All right. If your Hmax is equal to range, these will be cancelled. Tan theta will be equal to 4, or you can say angle of projection theta will be equal to tan inverse 4. So that is another condition. This was the condition for range to be maximum. This is the condition for which the range and maximum height will be equal. All right. I hope everything is clear to you. I have brought a lot of problems for you, but because of the technical glitch that got involved today, we may not start with the good level problems today, but it's okay. There is a lot, there are a lot of other things to be discussed in projectile motion. And I hope if you are comfortable with this, tomorrow, like in our next session, we can have the oblique projectile motion or projectile motion phase 2, in which we will discuss the remaining fundamentals and a lot of problems, all the major problems on projectile motion. So projectile motion is actually a big topic, and we must be investing a good time with it, and a good number of problems we should see. Kind of starting of mechanics is going on. So let us have once again projectile motion session tomorrow. Are you good with it? Okay. So what you have to do for that? You must be following the rule of revision. Means before you sleep tonight, your last half an hour or 45 minutes of the day must be dedicated to the revision. And if it stretches up to 1 hour, then also it's fine. Yeah, you'll be happy. Okay. Right? Chaliye. So these are the things. You can take the screenshot. You can revise from the screenshot in the, time breaks, short time breaks in between. Okay. Chaliye. Now let us talk about the energy consideration first. Energy consideration. So here we are talking about, we have talked about 7 parts. First of all, let me show you the diagram again. This was the projectile motion, x-axis, y-axis. NCERT consideration is this only. And here you have u velocity of projection, theta angle of projection, like this. If you understand the variation of velocity with time, so I will say here, this is u cos theta, and it won't change. Everywhere it is u cos theta. Topmost point also it is u cos theta. U cos theta. See, horizontal component of velocity will not change here. U cos theta. Why horizontal velocity component is not changing? Vx is always equal to ux plus ax into t. Okay, ax into t. But this ax is 0. So Vx will be always equal to ux as there is no acceleration in the horizontal direction. Okay, but Vy will be equal to, like, vertical component of velocity. What will happen to this? You'll say initially the vertical component of velocity is u sine theta, but that will keep on decreasing. That will keep on decreasing, and at the top the Vy value will be 0 at the top, and here then it will keep on increasing in the downward direction, and here again it is u sine theta. Here again it is u sine theta. All right. So there are few things which I will relate here and keep writing for you. See, first of all, if I'm writing acceleration as a function of time, acceleration vector, so I'll write it as ax I cap plus ay j cap, but this ax is 0. So you can write it as minus g into j cap, or can also be written as g minus j cap. Minus, in vectors, negative sign only contributes in the direction. All right, these are the things. Number 9, if I talk about velocity vector, then that is Vx I cap plus Vy j cap. So that will be ux plus ax into t I cap plus uy plus ay into t j cap. When you substitute all the values keeping ux 0, what you got is u cos theta I cap plus u sin theta minus gt j cap. And the last thing for today, that is displacement vector or position vector. Suppose you want to write, then this position vector will be sx in I cap plus sy in j cap. As you can see, in x-axis the nature of motion is uniform, so can be written as u cos theta into t. U cos theta into t. Okay, u cos theta into t, velocity into time, I cap. And when you apply s equal to ut plus half a t square because of uniformly accelerated in y-axis, you can write it as u sin theta into t minus half gt square, minus half gt square. All right, so j cap, and this is in j cap. So obviously I would say that here we have learned how to write the velocity vector, how to write the acceleration vector, and how to write the position vector in terms of time, or how it varies as per time. Okay, then there are kinetic energies, potential energies, angle of elevation relation, other form of equation of trajectory part, many things are there, but let us have that discussion tomorrow. Today let us stop here with the 10 parts, and I'm just now you can take the screenshot. All right, so let us stop here. Make sure you revise everything. You don't have to read any other book. You don't have to see the NCERT right now. You just have to go through these notes. Get prepared mentally tomorrow. Tomorrow we are going to have a very nice problem solving session with the remaining topics of oblique projectile motion. All right. Till then, stay smiling, stay healthy, enjoy your family time, and take a short break. After that, you will be having your chemistry session. All right, guys. All the best. Enjoy the day. Bye-bye.